Next, we're going to find the vertex of a parabola using completing the square. So basically, we want to get our function into vertex form from standard form. Right here, down here, this is standard form. So the first thing we're going to do is that if a doesn't equal 1, we're going to pull out a factor of a. Then we're going to square half the coefficient of x, our b, so like b over 2 squared, and add and subtract this to our equation. If I add something and I subtract it at the same time, it's like I did nothing, right? It's like I added 0. Then we're going to factor the trinomial as a perfect square and combine the combine the remaining constants. Combine the remaining constants. So if I have f of x equals x squared minus 4x plus 5, I'm going to square half of our b, so b over 2, and I'm going to add it, and I'm going to subtract it. Now, I didn't mean to write b. I meant to write -4. So I'm adding it, and I'm subtracting it. Let's try this again. Minus 4 divided by 2 squared minus -4 divided by 2 squared. So now I have f of x equals x squared minus 4x. -4 divided by 2 is -2 squared is 4. And I'm also subtracting 4 and adding 5. Notice this part right here in front of the subtraction symbol, this part looks like a perfect square trinomial, like when we were completing the square. So now I have f of x equals x minus 2, because it becomes of the form x minus b over 2, x plus b over 2. Going back to completing the square, section 8.1. If you aren't familiar with it, look it up. And then we combine the remaining constants. I've got -4 plus 5, which is a positive 1. So our vertex, because this is in HK form, our vertex is when x is 2, k is 1. So that's our vertex, when x is 2 and y is 1. Let's do a couple more examples of this. So what we want to do is we want to get our function into vertex form. So if a doesn't equal 1, we're going to pull out a factor of a. So I'm going to go ahead, I have f of x equals, we'll just ignore this constant, -3 times x squared minus 2x. I pulled out a factor of -3. -3 times -2 gives me a positive 6. I've got my -1 over there. What I'm then going to do is I want to make this a little bigger. I then am going to add and subtract our middle coefficient. So I've got -2. I've got to add -2 divided by 2 squared and subtract -2 divided by 2 squared. So I have f of x is -3 times x squared minus 2x. -2 divided by 2 is -1, squared is positive 1, -1, -1. This part is a perfect square trinomial. So it's going to factor to f of x equals -3 times x minus 1 squared. And I combine my constants for a -2. So my new vertex is when h is 1, right? Because it's got to be in this negative form. So it's okay that I just take the h part. I don't take the negative with it. And k is a -2. So my vertex is when x is 1, y is -2. So now let's find the formula of a function given its vertex and one other point. So I want to determine the quadratic function with vertex 1, -5, and y-intercept is -3. What we're doing is we're solving for a, and then we can write the quadratic function. So if I have f of x is a, which I don't know, times x minus 1 squared, which is my h, minus 5, which is my k, I just still don't know what a is, but I know my y-intercept is -3. So that means when x is 0, y is -3. So if I plug in 0 for x and -3 for f of x, which is the same as y, I'm able to solve this function. So I have -3 is a times 0 minus 1 squared minus 5. I'm going to add 5 to both sides. I have 2 is a times -1 squared, which is 1. So I have 2 is a. So then my function would be y equals a, which is 2, or f of x, sorry. Let's do f of x because it's a function. 2 times x minus 1 squared minus 5. So this is our quadratic function. And if I went ahead and FOILed this out and distributed and subtracted 5, we could get it from vertex form to standard form, but I don't have to do that. Next, let's determine the quadratic function with vertex 1, 4 that passes through the point when x is -1, y is -8. So here I'm given my hk, so I have f of x is a times x minus 1 squared plus 4. And I'm trying to solve for a. And I'm given some key information. I know that my x is -1 and y is -8 as a point on this graph, so I can substitute them in. -8 equals a times -1 minus 1 squared plus 4. So -8 equals a times -2 squared plus 4. Subtract 4 from both sides. -12 is 4a. So if I go ahead and divide both sides by 4, I get a is -3. So I can write the quadratic function in vertex form as f of x equals -3 times x plus 1, not plus minus, my apologies, minus 1 squared plus 4.